Welcome to Edivon. For over 30 years, we have provided premier technical teaching equipment across the globe. Our product range covers most technical areas which include engineering, physics, electronics, communication, and renewable energy. Every Edivon product is designed, manufactured, and quality controlled at our headquarters in Madrid, Spain, under several quality standards. Today I will discuss the Edivon EEICI unit. This unit is for the Charpy and Izod Impact testing, which is a type of destructive test that provides the toughness measure of a material and indirectly its ductility. These two types of impact or resonance tests use a falling pendulum to break a specimen and use the final height to measure the energy absorbed by the specimen. Now I'm going to cover the components of the unit and demonstrate a practical exercise. Here is an exact view of the EEICI unit. The pendulum, which is supported by bearings on one end and is 330 millimeters long. On the other end, we can mount the appropriate hammer for the Charpy test or the Izod test. A graduated disc with a dial indicator that will display the energy used to break the specimen. The holding system for the pendulum at the initial point of the test, allowing us to keep the initial energy constant across all tests. The pendulum release handle that will release the holding system and make the pendulum fall, impacting the specimen, and a transparent protection cover that allows the safe viewing of the experiments by the student. Here are the two setup possibilities of the EEICI unit. In the Charpy method, the specimen is simply resting on its two ends. There is a gap between the stands with a distance of 60 millimeters. The hammer that impacts the specimen is in the shape of a wedge whose sides form a 30-degree angle. In the Izod method, the specimen is fitted vertically and receives the impact at a distance of 22 millimeters from its support. The Izod hammer is used to impact on specimens that are fitted vertically. The Izod clamp is composed with all the accessories needed for supporting the specimens according to the standard ISO 180. The Charpy hammer has the shape of the letter C and is used for impact tests on specimens that are supported on both ends. The Charpy clamp is composed with accessories needed for supporting the specimens, according to the standard ISO 179. The Edivon Charpy and Izod Impact Testing Unit meets all of the required standards of the ISO International Standards. Length of the pendulum between the pendulum's rotation axis and the point at which it will impact the specimen in meters. The initial angle from which the pendulum is released with respect to the vertical expressed in degrees. The potential energy for each test of the pendulum in its initial position with respect to its position in the moment of impact is expressed in joules and meets the required standards. The supply includes masses for increasing the potential energy on the Charpy hammer. Each mass is 2.5 joules, providing the appropriate potential energy by applying one, both, or none. The test specimens are made of different plastic materials. They are made of PVC, polyvinyl chloride, PTFE, polytetrafluoroethylene, also known as Teflon, PMMA, polymethyl methacrylate, commonly known as acrylic. They all have notches in order to make their breaking easier. Their dimensions are 80 millimeters length and its cross-sectional area is 10 millimeters by 4 millimeters. Additional items included with the supply kit include all necessary fasteners with Allen keys of 4 millimeters in order to tighten the specimens into the clamps. The following is included with the Edivon unit: 8 manuals, including a user manual that explains the scientific theory being studied, any related mathematical equations, the function of each component in the unit, and how the unit is operated. Each unit is designed and manufactured under strict quality control
which allows us to offer a 3-year warranty against any manufacturing defect. We assure full customer satisfaction.
Now I will demonstrate the unit in normal mode. The objective of this exercise is to determine the energy needed in order to break specimens of different materials using the Charpy method.
First, place the Charpy method vices on the lower mounting plate. Screw these in the exterior holes. Use the Allen key to tighten the screw, securing the vise. Then attach the Charpy hammer to the pendulum. Raise the pendulum manually, placing it at the starting angle. Then adjust the indicating needle to the 0 position in order to measure the final angle. Place the specimen of chosen material on the Charpy vices, ensuring that the notch is centered. It is important to close the safety cover. Now we can release the pendulum using the release handle. The Charpy hammer impacts the specimen. Now we can record the final angle. Practical possibilities of the unit are included with the unit manual. These include experimental determination of the energy needed in order to break specimens of different materials using both the Charpy method and the Izod method. Another possibility of the unit is the experimental determination of the pendulum's friction losses. Thank you for watching this video. A link to our website can be found in the video description below. For more information, please contact us by phone or email. We look forward to talking with you.